This is a full-body avatar editing machine that we developed at Billiver. So if you look, there are female characters, male avatars, and you can exchange various parts, such as body, legs, feet, and various animations such as running and working. So what we're going to be doing today is we're going to be applying full-body avatar capabilities to the MozillaHub. So I'm going to walk you through the process. Now we're going to close this part and set up our development environment. The sources are as follows. I forked the master branch, which is the main branch, from MozillaHub GitHub. So I'm going to set up a development environment. But I'm not going to go into detail here, because every development environment is different. I'll just copy and paste from my predominant development environment. And the Korean side was missing a lot of resources. So I kept getting a lot of error messages during development. I'm just going to populate those missing resources that I found during the development process. And I'm going to include resources as well. Let's go ahead and run this. I'm in the Docker environment, so I'm going to open the container. It's going to take a little while. This creates a setup a development environment with the necessary environments for Hubs development. I'm now doing an npm install. That's going to take a little while. I've done all of the npm install and now I'm going to run it. I'm going to run the client. I'm going to run admin as well. I'll open 2 Chrome windows to run it. I'll run one as a secret window so that I can use both. So I go to the site here. I create a room. I go into the room, and my full body avatar is set up here. This is what I've already done, but let's choose another avatar. So we're going to go ahead and select the avatar that we created with our avatar editor, and we're going to run with that. And you don't need to change any of the source at all to do that. Let's go ahead and see what this looks like from the other side. Oh, I see it floating in the air. It looks fine, except it's floating in the air. The original avatar looks fine, but it's in the air, and the arm looks weird. So we have these problems. We're going to solve them one by one. First of all, we need to solve the problem of the full-body avatar floating in the air. In the case of this issue, Hub HTML, is that it is in this 1.6 location. At this location, it's set to 1.6, so the avatar will be anchored at a height of 1.6 relative to the avatar's eyes. So if you actually look at it, it's a half avatar. I'll call it mock-up. In the case of this mock-up avatar, I don't think it can be that long. The eye is set to a height of 1.6, which is why it's floating in the air like this. I think the height is probably around 1.6, but I'm not sure why it's so high. There's a reason, probably. So what we're trying to do is, if it's original, we're just going to let the old source to run as is. And if it's a full-body avatar, we're going to change the source to adjust the camera position to this avatar's eyes. And where the source for that is, there's an IK controller in the component. There's a source for this. So if you look in here, if you search for an IK controller, there's one in the avatar root like this. So we're going to have to do a little bit of tweaking here, but if you want to see where the code is, it's right here. You can see that we're changing the avatar position. Adjust the camera position and set up a matrix to align the head's position with the camera. So we have a 1.6 height camera position. Here's the code to lock the avatar like this. So we need to change that. But before we do, full body avatars are a little different from traditional avatars, in that they literally have arms and legs. So if it has arms and legs, it's full-bodied. And reposition that other, full-body avatar. And if it doesn't have arms and legs, I'll just change it to run this existing code. In order to do that, you have to load the arms and legs. If you look here, you have to set the eyes, left eye, right eye, head, neck, and so on. But I didn't understand how you could code like this. Because it seems like we could just access everything as this, left eye. But I didn't know why I had to use the schema, so I deleted the code and tested it. But I didn't find any problems or abnormalities, so I deleted the existing code from the schema. Then we'll add some code related to the update. So we'll add arms and legs. As you can see, before, we only had left eye and right eye. You could tell the difference between a left eye and a right eye. Now we have left arm and leg, right arm, right leg. That's a lot of parts to keep track of. So we changed the source so that we can manage them as left and right. And now that I have my arms and legs, oh, and one more thing. It says, left eye, and, right eye. I'm going to go ahead and fix that. And I want to save the left and right. So I'm going to go ahead and fix left eye to left.eye and right eye to right.eye. I don't think that's a big problem. Then we can recognize the limbs. That's where we were in the tick. We were talking about the fact that we need to modify this. But we're going to go ahead and add the left and right that we just added. So if I have a left and right foot, this is how I change the code to move the camera, not the avatar. Alternatively, we could change the source to run the existing code without the limbs. With that out of the way, let's give it a run. Save, and the source is now reflected. So let's go ahead and load it again. Let's move the mock-up. There it is. The full-body avatar is now attached to the ground, with arms visible. It's not floating in the air. The mock-up is still in the air. Why did that arm show up? To get rid of that arm. So it was supposed to be hidden when it wasn't VR. So now that it's out, it's going to be a problem here too. It's not left hand, right hand, it's left hand, right hand. And let's go ahead and say left hand, right hand. So, what happens? Let's turn it all off again and reconnect. Yes, I lost its hand. Mock-up lost his hand, and full-body avatar didn't lose his arms, but it was deformed in a weird way. What we need to do now is modify the full-body avatar so that the hands are intact. If there's an arm, we need to show the hand. So I think we can modify this part. I think this is the code that updates the hand's position, but it's also hiding it. So if you look here, that visible is set to hide depending on the controller. So we're only going to run the code if the arm doesn't exist. So if upper arm exists in the left or upper arm exists in the right, then I probably shouldn't run it. Like this, it should work. Let's refine the code a bit more. So what this means is, it comes down to whether or not it has arms. If it has arms, we'll add some code to it later. If it doesn't have an arm, it runs the existing code. But for now, let's just write some code to just run the case of no arms. Now, let's see if we can get our hands to come out if we're full-body avatar. So we've got mock-up coming in. First off, if you look at the mock-up, no arms, and if you look at the full-body avatar, you can see that the hand is still intact. It's moving, but it's not animated yet, so it's a little awkward. So that's the implementation of the ability to load a full-body.glb file and load it into Hubs. So we're going to add an animation. To add an animation, I need to create a component. We're going to create a component called full body animation. And where we add that component. And those avatars are networked to each other. So if you're going to change an animation, you need to make sure that it's going to be able to be shown to other avatar users. To do this, it seems appropriate to communicate through a networked avatar. However, as I was working on this, I realized that while I define someone else's avatar or remote avatar as a networked avatar, this definition does not apply to my own. Now, what I found was that this entity was itself, but it didn't have networked avatar components applied to it. In the other code, you explicitly set things up. So I'm just going to explicitly add it. And we're going to create another component called full-body animation change to tell this networked avatar that full-body animation has changed. So, now we need to play the animation, right? We need to play an animation, and we need to put that component right here. I'm going to add play to avatar root. And I'm going to add one more avatar root. In my case, I'm going to add something to this. So, full body avatar and full body animation have both been added. Full body animation change has been added to myself. When I change something about myself, I want this networked avatar to let me know. So I have to make some changes to the networked avatar component. There's networked avatar. So here's what I'm going to do. I'm going to do avatar pose. By default, we're going to do idle. Now, you can see that I've got either idle or I've got the left upper arm, the left lower arm. That I was using in the AK controller, and what that does is, if you just look at it in Blender, it's in the defined here. It's just fetching the values that are applied here. And even if it's idle animation, there is an idle animation in the animation. So it's going to allow us to set this value. So we're going to come back and share with you the current pose animations of that avatar through networked avatar. So networked avatar, when it's added like this, the way that we're able to communicate is we have network schemas. Networked avatar is also defined here, so it's defined in the schema. If you modify the networked avatar, it synchronizes all the data together. So we've declared variables that allow us to pass data back and forth. And we've also categorized some of the components that we're going to use. So let's go ahead and create a full body animation component. We had two separate components of full body animation. One is full body animation change, but with a full body animation change component. The component takes input from the user to update the current state. So, it takes user input as follows. Based on user input, at every tick, it interprets the user input and sets the appropriate animation accordingly. So we have front and right. If right is minus, that means left. If front is minus, that means back. So if they're both equal to 0. So if they both have a value of 0, then the default state to just be idle, and I need to add a definition to that animation. So I added this constant value to it like this. If you press the Shift key to run, that boost is activated. If you use a joystick or a pad, or an analog trigger, the right or left front can go over 1. But you can use that as a boost substitute. So when a boost is pressed or depressed, or if the light or front value goes over 1, it's considered running. If not, just interpret it as normal walking. So if the light value is greater than the front, this means that it might be diagonal in some cases. You don't know if it's going forward or to the right. So in order to determine that, we look at which side has the bigger value going to the right is bigger. Then we're now moving left or right. If not, and the forward value is larger. If the absolute value is larger, it is supposed to run forward or backward. Okay, nothing special. And I've set the value through set current animation to the networked avatar. That's just normal code. And now I have to play it again. So when we define the full body animation play in Hub HTML, we had defined it, we had declared it. So for the full body animation play, I wrote this. So it's just a binder, and we have to find the animations to play. We have to know the root of the avatar. We have to know the components of networked avatar. So we can read the value. This is literally a mixer for animation. So if there's a component that gets removed, so we do this removal and then configure our code to find the individual elements we need, and that's the part where we actually play. So we're reading the value every tick. We want to read that value from the network avatar. This is how we configure our code to run a playback animation when this value changes. There's nothing special about that. It's just normal animation code that Three.js gives you. so there's nothing special about it. But it's kind of unique here, so it's going to be. Wait a minute. What's the number 2.3 and where that comes from? It's going to be like this. So we have each of the animations that are defined here that we saw in the Blender before. The speed of the animations didn't match the speed of the hubs when it was moving. So I set the animations to be 2.3 times faster. It's just a random value, so we have some room for improvement. So if it's an avatar file, if the animation is a bit slow, it needs to have a higher value. If the animation is a bit fast, it needs to be lower. So there's some improvements to be made to be able to do that. To be able to set that value. To be able to set that environment. It's just a constant right now. We're going to make some more improvements later on. But right now we're just going to set it to 2.3. That's it. So once you've got that coded, let's see if the animation actually works. Let's turn it all off, and bring it back up. Well, mock-up doesn't really have an animation. It just has a blink, and full-body avatar doesn't have an animation. Why doesn't that work? Let's load it back up. Maybe I loaded it before it ran out of compilation. That's right. I forgot. When you add a full-body animation component, you have to add it to the component altogether. I didn't do that. Let's load it back up. Mock-up, and full-body avatar, moves well. We've got running backwards, running sideways, we've got animation up to here. We actually had one bug in the development process. It was okay at first. But when we tried to change the avatar to something else, it wouldn't be able to be animated. This is a problem that I didn't have a good grasp of the hubs, but it works fine. This is a problem because it wasn't originally composed, full-body animation change, through networked avatar. I just simply said avatar root, and I defined a component here of full-body animation. And it was a component of the network schemas, and I added that in and synchronized it with full-body animation. If that happens, there was a problem with the animation not being synchronized when you changed the avatar. In this case, it's a template. So once that other avatar in the room does a join, that's going to be created. It will be either an instance or a session, but once it's created, the section will remain that way after it's created. But in this particular model, reloading the avatar, this part is reset, which seems to break the session that should be maintained. So we checked that it wasn't communicating with us. And so we now have avatar animations, full body animation play, and change. And now we're using the network for that reason as well. So that's the application of the animations. Now we're going to go into VR mode. Now it's just a normal 2D web browser. So we're going to switch it to VR mode. Using other devices. Entering VR mode. We're in VR mode. So, if I move this head, you'll see the avatar move, right? But if I move this arm, it doesn't. So I have to implement that. But if it's a mock-up, because it doesn't have arms, you just map your hand to the coordinates of the controller, the VR controller. So it's not that hard. But if it's a full-body avatar, if your hand moves, you have to move this arm as well. But if it moves in a straight line like a stick, it won't look good either. But then I thought about how I could move these arms naturally. I had no knowledge of 3D at all, so I struggled a lot during this part. So here's what I did. There was a technique called inverse kinematic. I took that and did a search on how to implement inverse kinematics in Three.js. And there was a simple class code function called iksolver. When I ran the source, this is the screen. When I move this arm, it moves naturally and well. So I thought, I can apply it to this screen, so I analyzed the source. Well, where is it? This is the source for that. It has a head, a lower arm, an upper arm, and several hands. It's called a target hand. I don't know if this is an existing Hubs or a full-body avatar GLB file, so I didn't have that. So I took this and did a little bit of shoveling. Because it didn't exist. When I try to put it in runtime, it keeps breaking modeling. Or is that polygon? So I had a lot of trouble with that because avatar broke. But then I realized it was simple. I'll talk about that later. This sets the angle at which the arm moves, the angle at which it rotates. In other words, you can't use this as is. I just had to look at it and go, oh, that's how it works, and find the right value to work with. And the key is this class called ccdiksolver. The source of this class is like this, and I couldn't use this source. Because in Hubs, where in that GLTF, it's loading. There it is. So GLTF model plus. Here, the function called inflate entities is doing something a little different. Internally provided by Three.js, the structure that Three.js provides instead of just using that structure. I couldn't just use the function that the Three.js provides, so I had to make some changes. I'll go through it step by step and try to explain it again as I implement it. But what I need to do is I need that arm to move naturally, right? This hand controls that hand in the IK controller that we saw earlier. So I need to make a hand target here in the update in the IK controller. This is hand and this is arm, so I don't have to move hand or arm. But I have to have a target point to move hand. This is the one that's marked yellow. I have to add it. It didn't have to have a shape. But it just had to exist in some way, so I just implemented it as a sphere, an invisible sphere. So what I did there was I just added it like this. I did left hand target, right hand target, and I just added it to my avatar. And I'm creating a class called full body iksolver, which I'm going to create right here. What I'm doing here is I've got a class called ccdiksolver that was provided by that Three.js. But I couldn't use that in the hub, so I wrote a customized source. So I organized the source so that it's easy to use only what's needed. The angle of the arm's movement, the angle of its rotation, and these are the values I came up with while testing. It has that to a degree, but we haven't refined the values, so we're going to have to update that a little bit more later on. Rotation isn't considered here, so we need to improve on that as well. Now we'll implement IKSolver, and add a target, and we're almost ready to go. The rest of it, every tick now needs a function to execute. Where to run, so the question of what to do should be the update hand. By the way, so in the case of this function, we're updating the hand of the mock-up avatar that doesn't have arms, and then the avatar that does have arms, full body avatar. That's going to have to be a little bit different code. So what we've done is we've just simply said if you have arms, execute the code like this. It's really not that difficult. Update the target with coordinates in the controller on the left to hand target, and the controller on the right will do the same. So the hand target position is updated, and when you run IKSolver, it rearranges the position at the point of the updated hand target. That's it. I'm just going to run this. Oh, it's not doing it. It's giving me an error. So let's see. 157th line 159. It's going to give me an error, not defined. Oh, I didn't add it. Let's see. I forgot to do import. So import. Let's load it back up. Before that, we need to change the avatar to a full body. If you walk into VR, your avatar's arms are out like this. And the reason they're out like this is basically because that's where the controllers are right now. If you move the controller slightly, you can see that the arm bends and moves accordingly. It's moving pretty good. That's definitely going to need some tweaking because everybody's arm length is different. So this controller is going to have a range of movement for everybody. Each player is different, so we need to reflect that. If the arms are shorter, when the avatar stands at attention, it looks like its arms are bent. I think this one will be a bit difficult, so I'll have to improve on it later. So that's it for the full body. Since this is the first version, we've only added very basic things like blinking. And the arm rotates, and the fingers squeeze and pinching. These are some of the things that I think need to be improved further. That's it for BELIVVR. Thank you.